The curve y, 9 minus 6 over x, and the line intersect at 2 points. So they meet at 2 points. Again, whenever you see intersecting or intersecting, meets, cuts, we understand we will have to be solving a simultaneous equation. Right. Now part 1, we have to find the points of intersection. So pretty easy. Here we have y, and here we have y. We can substitute into each other. So on one side you will have, so here we have y. We don't know y is also equal to this, so we write 9 minus 6 over x plus x equal to 8. Okay, so to eliminate this value, we have to multiply by x everywhere. You will have 9x minus 6 plus x squared equal to 8x. Okay, simplify. Let's send everything to one side. You will have what? So here we have x squared. Then we have 9 minus 8, that should be plus x minus 6 is equal to 0. So simplify. That will be x times x. That will be 3 times 2. That should be plus 3 minus 2 for this value of plus 1. So you will have x is equal to minus 3, x is equal to 2. Now finally, y is what? Y will be replaced back in our main equation. You will have 9 minus 6 over minus 3. That should be 27. Right? Sorry, I think it's a mistake. 9 minus 3 over divide by minus 3. That should be 11. Not 27. So if you think logically as well, 6 divided by minus 3 should be minus 2. So 9 minus minus 2 will be 11. Right. Now this one, y will be 9 minus 6 over 2. That should be 9 minus 3. That should be 6. So the passing point will be, first one is minus 3, 11. And then we have 2, 6. So these two are the points of intersection. That is part 1 of your question. Now for part 2, we have to find the equation of the perpendicular bisector of the line joining the 2 points. So pretty easy. So if you think about this, we have these 2 points here. This is the point. Let's call this A and B. So this is A and B. Now we're trying to find the perpendicular bisector, which is the one that passes at the midpoint at 90 degrees, right? So how would you find the equation of this perpendicular bisector? So pretty easy. To find the equation of a straight line, we must first know the gradient of a straight line. So first we have to find the gradient of P. Now to find the gradient of P, we have to find the gradient of AB, for example, right? We can use that. So let's find this. The gradient of AB by definition will be 6 minus 11 over 2 minus minus 3. That should be what? 6 minus 11 divided by 5. That should be minus 1. Okay, so you will have this is equal to minus 1. So by us knowing that whenever we have two lines which are perpendicular to each other, their gradient will multiply to what? So we have to know this concept will be minus 1. So from this we understand that the gradient of the bisector will be 1. Okay, so from here we know the gradient. Now we have to find this passing point. This passing point is the midpoint of AB. So M is equal to, so that will be x1 plus x2, that should be minus 1, then divide by 2. And here we have 11 plus this, that should be 17 divided by 2. This is my x value, my y value, so we have to use that to find the equation of P. So y minus 17 over 2 over x minus minus half, that should be 1. Let's cross multiply. You will have y minus 17 over 2 is equal to x plus half. Let's multiply everywhere by 2. You will have 2y minus 17 is equal to 2x plus 1. 2y is equal to 2x plus 1 plus 18. So 2y has to be 2x plus the value of, 17 here plus 18. So finally, y could be, we can divide by 2 everywhere. That should be y equal to x plus 9 as your equation of that line P, which is your perpendicular bisector. Now again, by definition, what does it mean? It is a line that passes through the midpoint of the line joining those 2 points, So it's the midpoint, passes through the midpoint, and it is at 90 degrees to the other line. This is by definition of the meaning of this term, perpendicular bisector. Okay, and that will be your question regarding the quadratic equations, or we can call this also the coordinates. I don't think it's geometry, this one. It will be more about quadratics and solving simultaneous equation.